In Algebra 2, section 7.3, we're dealing with logs and log functions. So the typical log is base 10, but we're dealing with other bases in this sense. So if you have a base b, so whatever b is, you can convert a log to look like this. So the base to the power of the answer equals what you're trying to log. Right? So if I have an example, it says log 3 to 27. Log base 3 of 27 equals y. Well, then the y goes to the power of my base, so 3 to the power of y equals what I'm trying to log, 27. And just like last section, when I get it in the same base, so 27 is the same thing as 3 to the power of 3, because 3 times 3 is 9 times 3 is 27. And because these bases are the same, then I can just get y equals 3. So before we get to that, before we get to solving, let's just, what was I thinking? Oh, yeah. Let's just practice on converting, and that's what 1 and 2 is asking, is just to convert it from one way to a way that we can solve, okay? So this is, my b is my 3. My x is my 9, and my y is my 2. So once I've identified it, I'm going to rearrange it to look like this. So 3 to the power of 2 equals x, which is 9. And this is in fact true because 3 squared equals 9. See how that works? So I wrote this problem wrong. It's not 3, it's supposed to be -2. Okay, let's convert it. So our b is 3, no, our b is 10, our x is 1 over 100, and our y is -2. So I do 10 to the -2 equals 1 over 100. Right, so let's check. 10 to the -2 is 1 over 10 squared equals 1 over 100. Ding, ding. This is then our answer. So hopefully that conversion process made sense. And now we're going to start solving equations, solving it if one of these letters are left as variables. So go ahead and pause and write this down. We just have one other board. Okay, so on number 3, it's asking us to write equations in log form. So now we have to do the opposite. But it's the same method. What we're going to do is we're going to identify. So if you look at your notes, it's b to the power of y equals x. And you transform that into log b of x equals y. So b equals 5, y equals 3, and x equals 125. So this would be log of 5 of 125 gives me 3. Same thing with this. My b is 27, my y is 1/3, and my x is 3. So 27, the log of, what is it? Log of b. So log of 27 of 3 gives me 1/3. So those are the two types of conversion. And then we're finally going to solve. So it wants us to find log 3 of 247. Log 3 of 247. So what I'm going to do is I'm going to attach an equals y on there. Right? So then I do the same thing that I was doing in the previous, right here, except I'm moving it from here to here. My b equals 3, my x equals 243, and my y equals y, because we're solving for y in this case. So let's plug it in to make it look like this. this is my key that I'm using. We're going to do 3 to the power of y equals 243. Now, this is a problem that we kind of got from last section. I'm going to take 243 and factor it, okay? I want it base 3, so I'm going to start factoring it by dividing it by 3. So 243 divided by 3. So that's 81 times 3, which is 9 times 9, which is 3 times 3, and 3 times 3. So this equals 3 to the 5th power, right? Ooh, it's supposed to be a 5. So I'm going to rewrite everything the same. So 3 to the y equals 3 to the 5th power. I haven't changed anything, right? It's still the same, 3 to the 5th power, still giving 243. But I rewrote it so the bases are the same, and then now I can focus on just the exponents, and my y would have to be 5. So in order for this to equal 243, 3 has to be to the power of 5. And that is my answer. So, hopefully that made sense. Pause it and write it down, and go ahead and try page 472, numbers 1, 3, and 5. 472, numbers 1, 3, and 5, and I will see you in class.